In episode 66, titled Adopt OSCAL for Submissions, we kick off a practical shift from static, human-only packages to machine-readable security data that moves cleanly through modern review pipelines. Open Security Controls Assessment Language, OSCAL, is not a novelty for later. It is a path to faster, more consistent authorization work today. By representing your package as structured data, you remove ambiguity, enable automated checks, and cut the manual reconciliation that often slows intake. The promise is simple: the same truth once, rendered for both humans and machines without hand transcription. When your organization sees that a single update flows to every artifact reliably, confidence rises and submission cycles compress. That is why this episode focuses on the first clear steps to make OSCL real in day-to-day practice. Before we change processes, we should ground the concept. Open Security Controls Assessment Language, OSCAL, is a standardized set of data models for representing security authorization packages in a format computers can parse and validate consistently. For FedRAMP, the models encode the content historically stored in documents, plans, narratives, inventories, controls, assessments, so reviewers and tools can analyze structure and references programmatically. The key advantages are repeatability and fidelity. Repeatability comes from schemas and profiles that define required fields and allowable values. Fidelity comes from stable identifiers that tie controls, components, and results together without manual find and replace. When you speak OSCL fluently, your evidence stops being a static bundle and becomes a living system of record. The first concrete task is to map your artifacts to their OSCAL counterparts. Your System Security Plan, SSP, becomes an OSCAL System Security Plan with components, control implementations, parameters, and interconnections expressed as linked data. Your Security Assessment Plan, SAP, and Security Assessment Report, SR, translate into assessment plan and assessment results models that hold procedures, observations, risks, and findings. Your Plan of Actions and Milestones, POA&M, aligns to the risk and task structures, so remediation work is traceable by identifier. Attachments remain attachments, but they are now referenced from within the model with hashes and purpose notes. Once this mapping is sketched, everyone knows where each idea lives in the data, which eliminates the drift that plagues document-only workflows. Tooling comes next, and it should be chosen with both authors and pipelines in mind. You will likely need schema-aware editors for day-to-day updates, converters to lift legacy content into the model, validators to enforce profiles and catch mistakes early, and a lightweight build system that can stitch pieces into a package. Pick tools that enforce schemas as you type, surface friendly error messages, and export both machine and human views. Favor pipelines that run locally and in continuous integration so authors get the same feedback the portal will apply. When editors, validators, and build scripts act as one guardrail, contributors spend time improving content, not deciphering cryptic errors at upload time. Stable identifiers are the spine of a trustworthy OSCA program. Establish naming and ID rules that remain consistent across controls, system components, inventories, and findings. Decide once how you will name components, how control parameters will be keyed, and how assets map to authoritative inventory records. Then carry those identifiers everywhere, in SSP components, in assessment observations, in POA&M tasks, and in attachment references. With stable IDs, crosslinks never break, dashboards correlate effortlessly, and reviewers can jump from a finding to the exact control implementation and back without hunting. Without them, machine readability devolves into machine confusion. Make IDs a policy, not a habit. Converting SSP narratives into OSCA is where the rubber meets the road. Begin by decomposing pros into model sections: components with responsibilities, implemented requirements per control, parameters expressed in machine-readable fields, and interconnections with their authorization context. Keep narrative clarity for humans, but make sure every claim has a structured counterpart: an implemented requirement ID, a parameter value, a component reference, or a control objective statement. This duality is powerful. Readers see the story in paragraphs, while tools confirm completeness and consistency in data. Over time, authors will write with structure in mind, which naturally reduces ambiguity and accelerates review. Validation is your safety net. Validate against the applicable FedRAMP OSCAL profiles early and often, treating schema and reference errors as build failures, not late surprises. Profile validation checks cardinality, required fields, data types, reference integrity, and allowed enumerations so you catch small mistakes before they escape into portals. When a rule fails, fix the source content rather than patching exports. Add unit-like checks for common pitfalls, missing parameter values, orphaned component references, or attachments without hashes. The more validation you automate, the less time you spend reconciling during submission, and the more your package feels like a compiled program that either passes or tells you exactly why it did not. Version control belongs at the center of OSCAL adoption. Store OSCL sources in the same repository as your human-readable documents, and track changes through normal commit history with clear messages tying edits to tickets, owner decisions, and dates. Tag release candidates, require peer reviews for structural edits, and preserve a trace from each reported metric back to the commit that produced it. This is how you turn what changed from a detective story into a two-click answer. Version control also enables branching for sensitive updates, like a pending control parameter change, while the stable branch continues to produce submission-ready packages without interruption. Packaging should be automated so you never hand-assemble an archive on deadline night. Build scripts should generate the package, include a manifest listing each file and its description, compute cryptographic checksums, and sign the integrity file. The same scripts should embed package metadata, such as version, profile references, and generation timestamps. When you hand off the archive, the recipient knows what is inside, why it belongs, and how to verify nothing changed in transit. Automation also ensures each run follows identical steps, creating a trustworthy trail from sources to delivered artifacts that auditors and assessors can understand without ad hoc explanations. A prevalent pitfall in early adoption is mismatched identifiers between OSCL data and uploaded attachments or parallel documents. The cure is discipline and reconciliation. Treat the OSCL model as the source of truth and require that file names, internal titles, and references in any supporting PDFs or images match the identifiers in the data. Run a reconciliation check in your pipeline that scans attachments and confirms the presence of the expected identifiers. If an item is missing, the build should fail with a helpful message. This small safeguard prevents hours of "what does this refer to" and protects traceability end to end. If the full transition feels daunting, take the low-lift path. Start with an OSCAL-SP export and iterate. Many teams succeed by first representing the SSP with components, implemented requirements, parameters, and interconnections, while continuing to produce the SAP, SAR, and POA&M in their existing forms. As confidence grows, move assessment plan and assessment results into the model so findings and observations reference the same control IDs and components already in use. Each step replaces manual crosswalks with native links and builds muscle without halting current submissions. Early wins build momentum because reviewers immediately see fewer inconsistencies. A short scenario shows the benefit. Suppose a control parameter, say an encryption minimum, changes to a stronger value. In a document-only world, authors update prose in several places and hope no paragraph escapes notice. In an OSCA pipeline, you update the parameter value once in the system security plan, commit the change, and let the build regenerate human-readable extracts and machine-readable packages. The assessment results and POA&M artifacts reference the same parameter identifier, so explanatory text updates automatically were templated. The package rebuild includes new checksums and a manifest entry with the updated timestamp. Reviewers see a single, consistent truth with zero scavenger hunts. Keep a compact mental checklist to guide adoption under time pressure. Model, validate, version, automate, reconcile identifiers. Model your package content in OSCL rather than freeform documents. Validate early with the FedRAMP profiles to catch schema and reference errors. Version everything like code so changes are reviewable and reproducible. Automate packaging so archives and manifests appear reliably with checksums and signatures. Reconcile identifiers across data, attachments, and any human-readable views so nothing drifts. Repeat this sequence until it feels routine. When it does, you will notice that submission conversations shift from format fixes to substantive security questions, which is exactly the point. In conclusion, adopting Open Security Controls Assessment language turns your FedRAMP package into structured truth, less time reconciling, fewer errors at intake, and faster reuse across agencies and cycles. By mapping artifacts, choosing schema-aware tools, enforcing stable identifiers, validating against profiles, version controlling sources, and automating packaging, you create a system that produces consistent results on demand. Adoption is underway the moment you run the first build successfully. The next action is immediate and empowering. Run OSCAL validation locally against your current SSP and fix the first 3 errors you see. That small movement starts the feedback loop, and the feedback loop is how the transition becomes permanent. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.